like Rafiul Islam. He's an industry person and now he's an assistant professor of AI Labs, DCG Data Core System India Private Limited. He will be delivering on the topic deep learning for computer vision, a journey from scratch to implementations of a real life use case. He is finishing his PhD in compressed sensing signal processing utilizing deep learning framework from IIEST Shibpur under the supervision of Professor Shanti Mahathi and Padma Shri Professor Ajay Kumar Ray. His major work or research experience includes artificial intelligence and machine learning, especially deep learning. He has more than 10 years work experience in the software industry and as well as academic institutions, namely Modern Software Service Private Limited, Bangalore, Neotia Institute of Technology Management and Science, Kolkata, and the Neotia University, Kolkata. Presently, he is working as an assistant professor in the AI Labs Academy of Research Vertical of DCG, that is Data Core System Private Limited, Kolkata. He has published more than 10 journals, and papers at national or international levels. Now, I will request Sir to start the session.
Thank you, ma'am, for this wonderful introduction. So as the session is mainly hands-on, so before going to the program, so I will take only maximum 10 minutes time to explain convolution and pooling operations that is basically required to understand the networks I will implement through my hands-on experiment. So in the first step, I will take a very common example that most of you may work with. And in the second half, I will try to explain and I will show you everything, every steps, how COVID, non-COVID images can be classified. So as for the both cases, we will use convolution, pooling. Those are the operations mainly used in convolutional neural network-based deep learning framework. So we need to understand this, especially when you talk about the size or dimensions after pooling or convolution operations. That's you need to understand. Unless and until you understand those things, you won't able to understand coding, how a model can be implemented in codings. So for example, say we are having 6x6 image, nothing but 6 number of rows, 6 number of columns. And if you notice this image, this is basically a binary 1. So you can consider as a two-dimensional matrix. Now in convolution operation, we have kernel. So kernel can have any dimension, any shape. So mostly we use square life shape. It can be 3 cross 3, 5 cross 5. Mostly we use in odd numbers, either 3 cross 3, 5 cross 5 or 7 cross 7s. So say we are having this kernel here. And now when this convolution operation will take place, means this kernel will be used, will be converted with this input image, and after that we will have some output. So how that output will be computed? So you can assume that that kernel is exactly placed over there and perform element-wise multiplication and addition. So if you notice this matrix, so these black colored digits are coming from this original image, and this portion is nothing but the sub portion of the image. And if you see, these violet color digits are the coefficient values of these kernels. So now element-wise multiplication is taking place, and after that we'll compute addition, and that will be the After adding, we are getting 3. That will be the output of this position. So when the kernel, you assume that over here, you will have, after element-wise multiplication and addition, you will have this value. Now, to compute the next value, next output, you need to shift that kernel from here to next position. And in that case, we need to define some stride, whether it is 1, 2, 3. So it depends on you how you are addressing the problem. So if stride is 1 means after one column, just again this window will appear here. Means we will consider this portion to calculate this value. So in this way, you can move this window, that means this kernel over this image, and again come down by one row and again calculate, you will have this activations map. Suppose we are having another kernel. So another activation map will be at the output. So if you notice this, we have only one image, that is black and white. Number of channel is 1. We have used 2 number of kernels here, and after performing convolution operations, we obtained 2 number of activations maps. Rather, I would say this is basically, as a whole, we say that activation map. Number of channel of this activation map is 2 here. That is equal to number of kernel you use. So what will happen if you use color image? So for color image, as you all know that there is 3 number of channels. So whenever you want to make convolution operation using a kernel must have 3 number of channels. So this is the first kernel or first filter. We have 3 number of kernels, 3 number of channels. So each and every channel will operate on this color image respectively in the similar fashion that already I have explained for the previous one. So again, if we use another, as a result, we will have activation map, and activation map again will have only one channel because we are using one filter. So don't get confused with the number of channel of the input image and the number of channels of the output activation map. You can always remember in this way that number of filter is equal to number of activations map. Now suppose we have another filter. So we will have another activation function, activation map there.
Your audio broken. No audio is coming. All of the make him presenter. Sorry for the inconvenience. We are trying to connect him. Actually, this is a network problem. We are trying to connect him.
Power failure.
Yes, power failure.